And okay, so this week we're going to continue covering how to use Altair and to do more complex visualizations. And so this week we're going to start with the mark, and which is to each mark will be represented an item in your data collection, and also talk a little bit about transformation and interaction. So I think especially the interaction part makes Altair different from, say, other visualization libraries or the other Matplotlib. Okay. Okay, and we'll start with the marks. And so in Altair, and you specify the marks you want to use by specify a particular method. So method is something with, say, a bracket at the end. And then you can tell or can specify the mark, and by specifying this star replaced with the mark you want to use, and can be point, can be line, can be circle, etc. And so here we are using a circle mark. So you have mark underscore circle. And if I want to use line, you will say mark underscore line, etc., etc. And also, and the method itself can take arguments or parameters and to configure. So if we don't put anything in the bracket afterwards, for example, you don't put any of these, and it will use the default settings with color, opacity, size, etc. But you could specify this, and by putting some parameters, and we'll see a list of all the available methods a little bit later on. But just for this as example, and we would import an Altair and dataset and the bigger dataset. And in this particular case, we're going to visualize the cars dataset. So we're getting the URL. So this is some dataset stored online. We're not on your computer, and we're just getting the URL. And then, so you say Altair, which is this Altair object, which you imported here. And so .chart is the main method to create the chart. And in the bracket, you have to set the dataset you use. This can be, say, a Panda data frame. In our case, we're using a URL, which refers, actually, this is a CSV file or JSON file. Okay, and then you set the mark, and then you set the encoding or the channels you use. And in this case, we're using circle, and we set the color to red and opacity to 0.3. And opacity just means the transparency. And when opacity is 1, that means completely opaque. That means not transparent at all. And when it's 0, that means completely transparent, which means you can't see, because if it's completely transparent, you can't see it at all. So anywhere in between 0 and 1 will give you something which you can still see, but you can also see through it, so you can see if there's anything after that. And so this is quite important. And if you're using, say, something like circle, because it might overlap each other, and then with the transparency, you can see if it's overlapping. And then we do the encoding. We map the x-axis to horsepower, and its type is quantitative, which is a Q. And then the y maps to the miles per gallon, and its data type is also quantitative. So, and this part in terms of encoding, we covered last week. So this is a shorthand. You can potentially so do this in longhand form if you want to specify more. And you at least need the name of the attributes. This has to match exactly the column name or attribute name in your data set. And then this part is optional. Sometimes Altair can infer, sometimes not. I can't remember now when it can't. But it's always just to be safe, you can set the data type at the end. And so this is what it would look like. Okay, and so I'm gonna just do this quickly and in Visual Studio Code, so you can see what it looks like. And demo, okay. I have done this already. Okay, yeah, I did this already, so I'm not gonna type this again. And the code is exactly the same, I would see here. And so you import Altair, and you imported the data set, and choose get the data. From the data you imported, and this .cast.url. So this depends on the data set you use, and you would change. And but say for different data sets, you still need the URL. This name varies; it doesn't have to be that. And then you say chart URL mark circle, and color equal to red, opacity equal to 0.3. And for example, if I take this out and then run this, I'll be using this one. Okay, and so this is the default setting. And so you can see the color becomes blue, and there's still actually some opacity. If we change this back, let's say color equal to orange and opacity equal to 1. So that means completely opaque. That means you will not be able to see if it's overlapping, which is not ideal. Oh, I can't do 10.5, has to be between 0 and 1. Okay, so that useful when you have more overlapping, you can see clearly as an X map to the horsepower and Y map to the miles per gallon. Okay, and so you should be fairly familiar with this now. We've done quite a few examples like this before. Okay, so that's what it looks like. Okay, and the other thing you can potentially do, you can actually, instead of using, say, a shape or simple geometry, a geometry shape like the line, point, or circle, and you can even use an image. Okay, and then you need to, in this case, you have to tell Altair where you can find the pictures. Okay, so in this case, the data set we're going to use is a pandas data frame, so we're not using any existing data set. And because these ones doesn't have pictures inside, and it contains the X, Y, but also it has a image property, which saves the URL to a particular picture. And you can do this by, say, going online, Google a picture, let's say data science, and you choose the picture, just copy the link, that would work. And it's similar here, if I just type in that URL and into my browser, you can see, okay, that is give you this picture, which is the Firefox browser picture. Okay, and so this will be our data set. We have these 3 data items. And then each of them, besides X, Y values, also has a URL and pointing to a picture. So that's for Firefox, and that's for GIMP. It's the open source version alternative of the Photoshop, and then 7-zip, which is a way to compress files. Okay, and this part, we actually creating the visualization. So we started with the Altair object itself and dot chart source. So that's where the data is, and we're using a data frame. It's named the source. That's what's called source here. And then this time you can see we're saying mark image. We're not saying mark line or mark circle or point. We're saying image. That tells it I want to use image. And as mentioned before, and you can set certain parameters and in the mark function or method, and say previously we set the color and the opacity, And this time, we're going to set the width and height. Okay, so this is only makes sense for the pictures or for any marks which actually have width and height. So this is not the width and height of the visualization itself, but the width and height of the mark. Sometimes you don't set it here because you want to encode. You can encode the width and height to some attributes. Okay, and that's all you need to do. Then you encode X, which map to the X. So these are two different X's. And the first X map means the X channel, which is the horizontal position. And the second X refers to the X attributes inside the data set. So that means two different things. And then Y equal to Y. And then finally, the URL equal to image. So image is here, the image, which gives you the values of the where you can find the picture. And if you run this, and you get something like this. And so you can see, and X is 0.5, 0.5, and with a Firefox picture. So that's why, and you have 0.5, 0.5 with a picture of Firefox. And similarly, you have the other two things. That's the GIMP, that's the 7-zip. And once you change the image URL, it gives you different pictures. I can try that again. I'll just show you quickly. And in the code I did. So that's exactly the same. And for example, here, why does it? And I might change this picture to something else. For example, all I need to do, let's just say Photoshop image. Okay, let's say this is the image I want to use. Wow, that's a big one. And I'm not sure if you can see, I just choose copy image URL. And here, I can come here and just change this part, which sets the URL for the images for the second items. Okay, that's not the best one. Copy. No. Okay, let's just go there. This is the SVG. Oh, maybe work. Let's try. Okay, and so this is slightly different. We are using a file format called SVG. I'm not entirely sure if Altair can handle it. We'll try and find out. Okay, it doesn't like it, looks like. Let me see if it has any normal version, like usually, and it's a bit safer to get, say, just the JPG or PNG files. What about this one? Consent and copy image address. Let's change this one. Okay. So let's run this again. Oops. Still didn't have it. Did I miss anything? Okay, it didn't complain. It didn't have errors. Is that even PNG doesn't work? Sorry, does it have to be PNGs? Give me just 1 second. Let me see if I can find type. No, not very useful. Wikipedia, no, definitely not. But I don't want to download. I want to just use it online. Okay, let's give it one last try. This should be a PNG file. And if we run it again, oh, it still didn't have. I don't know why. Image. Okay. Well, I'll get back to the slides. May have to come back to this later and to figure out exactly why. Okay, and so we saw the one type of fairly complex mark, which is image, and you can also have other types of more complex marks. And in this example, we're looking at a box plot. And so box plot is just type of chart itself. And so it's kind of similar to a bar chart, but it shows the entire bar, shows the entire range, or I think not even the range. I forgot now, say the range of the data set, and I think it's 95%. And then the bar part is the middle to the second and third quantile of the data set. So it gives you an idea of the distribution of the data along the bar. And sometimes you have extra dots outside as well. Those are outliers. Okay, and then in Altair, and instead of say drawing different boxes and lines, you can just draw box plot as a complex mark. And so you say, hello. And so this part is the same as before. You import Altair and import the data. And in this case, we're going to be using the population data. I'll show you very quickly what the population data looks like. So we Altair, what the data set is called? Vega data set. Okay, Altair Vega data set. Vega data set data. Okay. Wow, that's not even population here. I didn't even try that one. Okay, I couldn't see population here, and we can give it a try. Maybe that data set was there, but it's now removed. And so in this case, and we say data.population.ul, and previously we said data.cars and .ul. So in this case, we change to population data set, and then you say Altair, and chart is the source which is the data here, and you say mark, this case we'll say box plot, and the encode wise, and the Y, it says people, and it says quantitative. Okay, so for the box plot, in this case, we only have one box plot or one bar, maybe not called a bar. And so it does not specify anything about access, and it's only just plotting the distribution of the value of people along the y-axis. And here it says properties, and this is the part actually setting the size of this chart. So its width and it's 200, and then the height is 300. That's the size of the chart itself, not the individual mark. So you remember we can set, say, the size of the mark here after the mark method. Let's do this quite quickly here. import Altair as out from we go data set import data source equal to data dot popu. Oh, there is one, but I couldn't find it. Dot URL on the page, so maybe it's somewhere else, or it seems to be able to find it, but I couldn't quite see it here. Anyway, we'll find out if it can find it or not. I'm going to just run this cell. Okay, I can just say source population.json. Maybe I'm not looking at the right one. So it says this links to this file. If I just type it in here. Okay, so that's what it looks like. It's a JSON array. It has year, age, sex, and people. I assume that's for different year and different age group, and the male and female maybe, and that's the population size. Okay, so actually in my work then, no, I don't want markdown. Let's do a code. Then I can say Altair chart. The data we're going to use is the source. We're using box plot. We're not going to change any settings of the box plot. And all I'm doing now is just say the y can map to people. And it's stated. Sorry, the attribute type is quantitative, so it will be Q. And we're seeing here, we can set as year, age, sex, or people. People is probably more interesting, which is a population, I assume. Okay, and then, okay, maybe I'll do this. And then dot properties. And these are some extra settings about it. Raise equal to 200. Yeah, height equal to 300. And if you didn't set these properties, that would also be fine. And Altair will just use its default value. Why is it complaining? Pylons. So it doesn't like. Okay. So you can't break it here, I think. Okay, the only place you can break would be here. Now it's okay. Okay, and you can put everything in a line or can write like this, just to make it a little bit easier to see. Error module Altair has no attribute chart. So that's an error. So it's about the chart, and the reasons it has to be capital C, and if it's used small case c, it cannot find that object. Okay, now it does. So that's the box plot. If I take out the property part and I can run again, it will do using the default width and height. And so the height look is okay, and there's a width looks a little bit small. That's why we used the property to make it slightly wider. Looks like this. Okay, and back to the slides. Okay, yeah. So obviously, and you can have multiple, and how do I say, bars or boxes, and in the box plot. So this is example, and we're still using the population data. Okay, and then here the difference is here is also the same, and there's only differences in terms of encoding. We're gonna encoding age to the x-axis, and here this again is not a 0, it's a capital O, and that means it's ordinal data attribute type. If you remember, ordinal is something it has orders, but you cannot do calculation on it. So it will be different, treated differently if you say this is an Q, which is the numerical data set. Okay, and this will be quite easy to do, and because all we need to change here is just adding an X, so we can do it. Oh, X equal to age, and I'm gonna do ordinal. Okay, okay, and then if you run, yeah, so we generated very similar, and you can see these are the extra dots, which are usually the outliers, which is not within, say, the 95% range. And just to see if I say this as Q, which is say I want to treat the age not as an ordinal attribute, but a quantitative attribute. Okay, and you can see looks still very similar, but the x-axis looks slightly differently. It would automatically calculate some ranges, which you think is good. In this case, make it slightly bigger, not just from 0 to 90, and which is available in the data set, add a little bit more. Usually there's also other small changes. For example, if it's a bar chart, and it will show you the width of the bar will be different, depends on whether you set it as quantitative or ordinal attributes. Okay. Okay, and so this has got something to do with the box plot itself. So not part of Altair. And so here, the outliers, which are these circles, and by default is defined as that's 1.5 IQR, which is interquantile range from the box. So the interquantile range, I think, is here. If the value is more than 1.5 times of that range from where the median is, then that is considered as outlier. And you can change this. For example, you can change this instead of 1.5, which is the default value, you can say 3 times. And in that case, then the less point will be considered as an outliers, because now you make the threshold, which is for the outliers, bigger than before. That's why you can see if you compare this one, and you have much more points, which is considered as outliers, whereas in the new one, which is this one, you can see much less points. And if you further increase this, and then even less points will be considered as outliers. Okay, yeah. And also, you can also not showing outlier at all. Okay, and then, so the way to do this one here is not by, for example, to say hide those points. Okay, what it does do, it defines, say, the extent is minimum hyphen maximum. So it just says the extent of the whisks, which is the bar, the name for the bar called, and in the box plot, and is from minimum value to maximum value. That basically just means the whisks will cover the entire value range. In that case, there will not be any outliers because everything will be within the minimum and maximum range. And that's all. So again, so that's just the different parameters for the marker, and you say extend to something else. So previously, by default, is extend equal to 1.5. You can change that to the value, or you can change that to the minimum to maximum. So this is predefined string. You have to be just typing exactly like this. Okay, so that's all we want to talk about in terms of mark. We saw a couple of more complex ones in the image, and then later on the box plot. Okay, and next part we're going to go on to data transformation. So this will be changing the data, or sometimes including filtering the data as well. Okay, and you have two options. Either you can just use Python to do this because Altair is in Python, but you can potentially even pre-processing the data in any software you want, for example, Excel or even R. And I mean, because you can do this quite easily in Python, so you could potentially, and most people would probably just using Python to do that, or even just pandas. So you can do this, or you can do within the Vega Lite, which is within Altair itself. So you have two options. You either processing the data before it's being visualized by Altair, or you can do it with Altair. And but say, for the second option, you can only do what is available in Altair or Vega Lite, and its data transformation tools is maybe not as rich as what say available in Python, but they cover the most basic ones, the common ones, and yeah, probably available. And so our suggestion is you probably want to use the first approach, which is outside or before you're using Altair. And because Altair is not really designed as a data processing library, it's really mostly focused on visualization. Ooh. Okay, and then the second approach becomes more useful when the data source is not a data frame. Obviously, and if the data can be installed as a data frame, and you can use pandas functions or methods to do this, which is probably the easiest. And when the source data is a JSON or CSV files, there are different other libraries you can use in Python to do processing as well. But in Altair, it has a bit more method, which is designed mostly for JSON or CSV files. Okay, let me move this one. Okay, and then the way to do this is using the transform method, or transform underscore, and the star will be replaced by the actual transformation you want to do. And this is similar to say the mark. When we say mark, you would say mark underscore and specify the specific type of mark you want to actually use. Here, the star will be replaced by the actual transformation method. And now we're going to see some examples. We start with aggregate. Okay. Okay, and then so aggregate basically just means summary statistics, and the common ones are the median, average, mean, minimum, or maximum values. Okay, so those are probably the most simple ones you can do, statistics. Okay, and then if you specify aggregate and in at least one of the encoding channels, say X or Y or size or something, and then the resulting visualizations will show aggregate data. So once you specify aggregation in one of the channels, and then the entire visualization will use aggregate. Also, because it's not quite possible and to show individual anymore once one dimension or one channel is using the aggregated data. Okay, and then the fields does not have aggregate function will be treated as group by. So let's say, okay, I think it's probably easier. So I think maybe this is slightly difficult to understand and probably easier when we see the examples. Okay, and so this is a simple example, and we're using the car data set. We are familiar with this now and have done this many times. Okay, and so here we're not doing, so we already is doing the aggregation. You can see here, and the x-axis using the mean, which is calculating the average of the acceleration, and this result is quantitative. So it's calculating the average of the acceleration. Okay, as we said, the other attribute, which does not have an aggregation function, in this case will be y, and it will be treated as a group by. If you have done SQL queries, then this concept will be quite similar. But in this case, what it does, it will calculate the average for each different cylinder numbers. Okay, again, this is the big O, not a zero, as it makes it ordinal. So you can see, so it will calculate the average for all the cars with 3 cylinders, or with 4 cylinders, or 5 cylinders, 6 and 8. Okay, and then you can see this is the mean of acceleration. I assume that will be the seconds. Okay, doesn't really matter. So this is the mean value. And so we are not calculating the average for the entire data set, but specified by this axis, which is different cylinder numbers. I assume you can potentially use this one for using other attributes from the data set as a way to group by. Oh, sorry. And can I just check, and is everyone can see my screen okay? Because I saw someone typing in the message say they can't see my screen.
I can see well.
Oh, okay. Thank you. Okay, yeah, maybe just take a little bit of time to load the screen. Okay, let's go on. Okay, and also what we are using here in the previous examples, we're doing the average on acceleration. This is the shorthand form, and the proper form will be like this. And I don't think you need to use x equal, but anyway, you can still put it there just to be safe. You say lt.x, and field equal to acceleration, aggregate equal to mean, and type equal to quantitative. And so is that exactly the same as this. And the advantage of doing this long form would be you can add more parameters after this. You can add other settings after dot, which you're not possible to do in the shorthand form. Okay, and the next one we could talk about is the binning. And so this is something kind of similar to the grouping, but here, and you group on the dimensions, and how do I say? You're not grouping using the other dimensions, and also the binning is directly to generate a counting of a number of records within your different ranges, and which usually is used for histogram. Okay, and in this case we are using the movie data set, and then we say chart movie. So the movie is this movie here, which is data set. We are making a bar chart, and in terms of encoding, under the x-axis. Okay, so here we are using the long form now because we want to including being equal to true. We can't really do that in the shorthand form, and so I have to use the long form. Not exactly the long form. So this is kind of like a mix of the long and short. And so the outer.x similar to this one, but still inside we are saying IMDb column Q. And so this is actually still closer to the shorter hand form. So it's like the mix of the two. So you say, and the property I want to visualize, I want to use map to the x-axis is IMDb rating, and this is quantitative, but I'm not showing individual ratings. We're actually doing a bin, so I'm creating a histogram. And the y-axis will display the count, so which essentially means they're going to be displaying how many records for each range. Okay, here it will automatically select what is the start endpoint, what is the range for each bin, and y-axis shows the number of counts. So I think this just means, say there are most of the movies, close to 1,000, has a rating between 6 and 7. So that's the most common rating. Okay, and yeah, and so here, and we are bringing something a little bit different, and we are creating a kind of color steps. So, and you can map and say acceleration to color. So that's straightforward. And what it gives you, it will give you a continuous color map. And if you didn't specify, it will automatically pick the color and pick what is the, say, the darkest and what is the lightest color to use. And here, and what you can do, and you can say, okay, instead of say have a continuous color scale, I want to bin them. So I have a few color steps instead of say a continuous color. And you say maximum bin equal to 5. Okay, and so this is a bit different compared to bin equal to true. Here you say I want to maximum 5 steps, and then Altair decide, okay, maybe 4 steps is better. So that's only has 4 steps here. Okay, and you can use bin equal to true, which will give you something similar to this. Everything will be done by Altair itself. And this, in this case, we are using a slightly different way. Bin equal to Altair.bin maximum, max bins equal to 5. So again, so this is closer to the long form. And you can say color equal to Altair.color. And so the bin equal to the values, the Altair.bin, and is how you, the common way to access any of these channels in Altair. Because in the long, for the color, you say Altair.color, for the X, you say Altair.x in the long form. And this will be one of the parameters, the one way you can set it. And maximum being equal to 5. I think you can also be even more specified, say what the maximum value, minimum value, how many steps, and they can calculate how many bins it will be for you. Okay, and I can just keep going on and didn't type these in the examples. And if you copy these code into a Jupyter Notebook or Jupyter Notebook, it should work straight away. I'm just going to keep going because we have quite a few things to cover. Okay, and so that was being essentially grouping and then calculate the number of count within each range. And the next one is filtering. Filter is remove certain things. Sometimes you get just too many items in your data collection, and maybe some of them are not relevant for what you're looking for, so you want to remove them from the visualization. Okay, and to add a filter, and you need to use chart.transform filter, and exactly filtering will be set up in the parameters in the bracket. Okay, so in this case, we're going to be using the population data again, and then say Altair chart pop. So that's the data set. Okay, the mark we're going to be using is area. So it's going to create an area chart. And in this particular case, it just means you're going to color the area under the line, fill it with some colors instead of just showing the line itself. And then the X will be mapped to the ages. So this will be the age. It's a ordinal again. And the Y will be mapped to the people. It will be quantitative. So this will be the population, I think. Okay. And if you don't have the filter, it will just draw a line, which shows the population for different age groups. Okay. And then here you can see what is added here is it added a transform filter. And so as we said before, you need to use this method. And this method usually doesn't have to be the first in the chain. So the chain means you have dot some method, dot again, a different method, dot again, a third method, and false, and so on and so forth. It doesn't have to be the first one. Usually it will be the close to the end of the chain. Okay, it says transform filter. It says datum dot year equal to 2000. Okay, if you remember, the year is one of the attributes in the data collection. Let me see if I still have it. Yeah, I still have it here. And you can see the year is one of the attributes. And in this case, I set that to 2000. So I'm only showing the data, the year equal to 2000 and the sex equal to 1. So the values will be only showing 1 and not 2. I think this is just one of the genders. So here, the datum, just remember, refer to individual data items or each individual rows. So that's like a keyword you have to remember. And this year and sex has to be the columns that you have in the data set or the attributes you have. And you can set, say, equal to. This is also something you need to be careful. For actual equal, you use 2 equal signs, not a single one. This is something related to programming. Usually when you use a single one, what it does is just to give the values on the right-hand side, give that value to the one on the left-hand side. And it is not to test whether they are the same or not. Okay, and then you can have multiple conditions to filter. In this case, we're going to filter on both year and the sex. Yeah. Okay, and maybe let's create this one in our examples. I think we already did all the import. Let's say pop equal to data.population.url. Let's run this. Okay. because we already imported Altair at the dataset before. We still have to do one more thing. Import datum. So this is something we didn't import before. We need to use that when we specify the filtering. Okay, and then okay, we'll have to use capital C. The data set we're going to use is called pop. The mark we're going to use is area. Okay, these are all fine. And actual encoding wise, the X will be to the age, and it's ordinal. Oh, I need a comma here. And Y is going to map to the people and it's quantitative. Okay, I'm going to just run this one now. And you can see this is what it looks like. And I suspect you have these sharp lines because you have two different genders, maybe. So for example, I can do the transform filter. We're going to find out if you have this like a spikes. Is that because you have the two genders, they have very different values? Okay, in this case, I'm going to do the first one. Just do one first. I will just say datum.sex equal to 1. Oh, do I have to put it in bracket? Okay, and I said you have to use 2. What if I do this one? Okay, it still works. Okay, and in this case, we're going to only just filter by gender. Oh, it doesn't work. I misspelled this word. Transform filter. Okay. I got it now. And so the reason we have this and spikes, what happens is for each age group, and you have different years, and for each different years, and the population actually changes, and they start with quite small. If you look at the data set in the 1850s, and later on in the new data set, this becomes much larger, and so it's actually drawing 1 point for each of the year, I believe. So that's why. So if I change the data item dot year equal to 1850, and I run, okay. And so this looks more interesting, but also you still have these lines. And because for each age group, you still have 2 sexes, and either is and 1 or 2. I assume that's for male or female. So if you need multiple conditions, then you have to put this one in the bracket. Is that double end or single end? Okay, a single one will be fine. And then say sex equal to what? Datum.sex. And I can run again. Okay, now it looks much better. And it shows and the general trend in year 1850, and then for the sexes one, I might have to guess now, I assume that's male or female. And you can see the trend is quite different compared to what we have in the picture here. It's actually just going downwards all the way. So people dying at all different ages. For example, we're adding data example and examples in the lecture slides. We said year equal to 2000. And if we run, and you give you a quite different range. So actually, the largest population is between, say, 35 or 40. rather than in the previous ones. Okay, and so this one saying here, and there's something called field predicts, and which can do something similar as a filter function. Okay, and so we're creating a chart very similar to the previous one here, and we change the marker to line instead of the area before. So, but it's really the same data. And instead of saying transform filter, put in these two conditions, you can say out dot filter equal predict. So filter equal predicate. And predicate, just these expressions, these are called predicates. And this says very specifically, just say only for equal ones. And you can say field equal to year and equal to 2000. So that means year equal to 2000. Okay, and personally, I think maybe this is slightly easier to read compared to this. Okay, but the advantage of this one, you can add more predicates, and you do something called field one-off predicates. Okay, and so that means this one is the equivalent of or. And so imagine here, instead of and, you can use an or. And you can express in this way. It says the field is either 1990 or 1950 or 2000. Okay, so that's why you get these straight lines here. So yeah, so this is the 1900, this is 1950, and this is 2000. Okay, and this is one of the way to do the ORs. Okay, and this one, it says this is the range. Again, so it's actually just say, and I'm looking within the range of from 1960 to 2000, and it will list all the year values in between those two. So it would have 1960 and 2000. In between, you have three other ones, and each of them would have a line, and this is what it looks like. And here you have these like a different shade of blue, because when you do the mapping, and you said color is a ordinal attribute. Sorry, the year is ordinal attributes. And so for the ordinal ones, and it were not using, for example, different colors to show an ordinal. Different colors is usually or used to show different categorical attributes, which does not have order, because these ones has an order. So it's where you automatically use different shade of the same color to show it. Okay, and so that is about filtering. And this is kind of the last part, but we still have quite a few to go, is covering about in terms of making the chart more interactive. Okay, and so we understand these three different concepts called selection, conditions, and binding. Okay, and so the selection says when user interact with what part of your chart, and it will trigger some interaction. So it can be a mark in the chart, or can be the x-axis, or something else. Okay, and then the things to be triggered and could be mouse click or drag or even just mouse over. Okay, okay, and then the input does not even have to be in the chart itself, and it can be outside chart, and like a drop-down menu or radio button, which we'll see very soon. Okay, and then the condition functions, well, basically connects to the user interaction, for example, from a drop-down menu or radio button, and kind of connect or link that to part of the chart. So for example, where the user changes the values in a drop-down menu, and I don't know, say maybe the colors of the chart will change, and then the condition would connect the drop-down to the color of your chart. And this could be other attributes, or becomes clearer later on. Okay, and then finally the binding, and which creates a two-way binding between the selections and the input element. Okay, so the two-way means, and if you change in the input elements, for example, you do a different selection in the drop-down menu, that would change the chart. But also, if you make any changes in the chart, and it will be also reflect in the input elements as well. And for example, you somehow change the colors of your chart, and then the color selection in the drop-down menu would also change as well. That's called a two-way binding. So it goes both ways. It both goes from the input to chart, but also from chart to input as well. So they always match. Okay, we're gonna see in examples. We're gonna build this step by step, and so we're gonna using the cars data set. And for the first step, we'll just create something we already done many times, and we map the x-axis to the miles per gallon, the y-axis to the horsepower, and the color maps to the origin, and where the car comes from or made from. Is that which continent? Is it Japan, Europe, or America usually? And it gives you something like this. And we've done this many times already, so we would exactly know how to do this. I'm gonna just type this one in here. Let me see if I just give it a cost. Does it means anything? No, it doesn't understand yet. Equal to data.cost.url. I think that should know. Yeah, that'll be fine. And then we're creating the actual chart itself. We've done this many times already. But just using the data set, which is the cars, and the mark will be point. We're not going to change any default settings, and we'll do the encoding. The X will be miles gallon, and this will be quantitative attributes. Again, so the name have to match the attribute name in the actual data set, and which you need to check. And Y got to map to horsepower. Again, so the capital or lowercase, uppercase or lowercase is very important. Again, it has to be matched, otherwise it might not be able to find. And finally, the color, we're going to map to origin. This is another attribute. This is going to be nominal. That means just categorical attributes which does not have an order. And again, we have to use American spelling. We can't use British ones, otherwise it doesn't recognize. Okay, and so we run. Why there's nothing show up? Did I miss anything? Oh. Okay, let me just copy these one as well, which I don't think I will need them. and run this one again, and run this one again. Huh. Okay, I probably I misspelled here, and it should be horsepower rather than horsepower. Okay, and now we have the visualization similar to this one we've seen before. All these points, and each point is a car, and the x-axis is the miles per gallon. The y-axis is the horsepower, and color indicates the origin or where the car comes from. Is it Europe, Japan, or USA? Okay, and so far, and there's very little interaction yet, so we're going to add them gradually. Okay, so first we're going to allow people to do interval selection. So this is essentially people drag a box on the chart. So the method provided by Altair is called selection underscore interval. And then we're going to bind, if you remember, that's the last step, is this brush, which is the interaction itself, to our chart by setting the selection property. Okay, and so what it does is, so this part is the same as before, and then we adding a selection. So adding, say, user interaction. In this case will be brush. Brush essentially is a selection interval. Okay, I'm gonna just try to see if I can skip defining the brush altogether. I just say outer.selection.interval. It might work, might not. So we need to add selection. So this is where all the interaction comes in. alt.selection interval. Okay, let's run this. And okay, it works. And so you can see now I can make a box. That's the interval selection. So, and to be precise, this is 2D interval, so both X and Y axis. And that's why you draw a box. And you can do just 1D interval, which is just a range on one of the axes. But because this is a scat plot, we have 2D, so you draw a box. And if you click anywhere on the chart, and it removes the selection. Obviously, currently, after we did the selection, we haven't done anything yet. So all we can do, and it's just creating a selection box. Okay, yeah. So we have seen this one. Okay, then now after the selection, we're going to use condition and to make the chart change based on the selection. And so in this case, we're going to need to use the condition function. Okay, so we're going to tie the color to the origin columns for the points in the selection. And so previously the color is just equal to, if you see here, and here the color just equal to origin. Okay, now we say we only show color at origin if it's being selected by the brush. Okay, so this is what this line means now. Okay, so it says outer.condition. So this is the way you specify condition. And then say for when it's being selected by brush, the color would map to the origin, and its data type is nominal. So that's still the same as before. And this is when it's not selected, its value would be light gray. So that means if it's not selected, the colors will be gray. So basically it has no color. So, and it does not show the origin at all, it just has a uniform, the same color will be light gray. And it will look something like this. So only the colored parts now, only the selected part now would have color. Okay, I'm gonna just try this quickly. Okay, so now it will be easier to do the brush thing. Let's define brush first. Brush equal to out dot, and just make it a bit easier. Selection interval. Make sure I type the right thing. Yeah. And then here, so first we here in terms of add selection, just brush, but also here, the color is not just the origin now. We're going to do out dot condition. Say when it's selected by brush, I'm going to show origin and otherwise. So this is a default value defined in Altair. And this default value would be light gray. So that means if it's not selected, it will be light gray. Okay. Huh? Ah, now it's working. So you can see now, everything outside the selection and is light gray, and it's only change color when it's inside the selection box. That's what it does. So when it's inside the box, it will map the color to origin. When it's outside, it will use this part, which is default, is light gray. I don't know if I can do blue. Then just says outside will be blue. Which certainly doesn't work as well, I think, as the light gray before, but maybe let's say light blue. Maybe slightly better. Yeah. So now actually, so we first add the selection, and then we added the condition which respond to the user selection. In this case, going to change in color. And depends on where you added the condition function, it will affect different part of the visualization. Okay. Okay, and previously or so far, the selection we saw is actually a interval selection, which allows you to do and say drag a box for 2D, and in 1D it will be just a drag interval on an axis. And you can also do single selection, which you just select single lines. Single data items from the chart. Okay. Okay, and so I'm going to try to show you how to use single as well. And so the first, and it's a little bit different, it's actually define the function in Python now. And we never done that before. And then all it does, and just return an Altair chart as the function, and using the selector. This is the input parameter. It will change, depends on, for example, this can be the brush, or can be other different types of selections, for example, a single point selection. Okay, and this would lead to something like this. Okay, and let me just put this one in first. In the code, just to save a bit of time. Code. So we define this function. Okay, it's okay. So what it does is, it returns a chart which using the data set, which is cars, and its mark is rectangle. So it's each data point is represented as a rectangle, I'm encoding the X position is number of cylinders, the Y is the origin. Okay, and then the color, as we did before, and depends on the selection. If it's selected, in this case, we don't know what kind of selector it is, which you can change. And we call the function, which makes it more flexible. And when it's selected, it will show the number of count within the selection, or otherwise, it just shows as light gray, which is the default. And this part just sets the size of the validation, which is 300 pixels by 180 pixels. And finally, the interaction, it says the interaction will be called selector. Okay, and so this one defines as a function. When I run, it's okay. It doesn't do anything yet. The function would only run once you call it. Okay, and so we're going to call it in the next slides here. Okay, so this is where you call the function. So call make example, and you can see here the function name is called make example, and then here we have something called interval, which is defined here. So this interval is a selection interval. So that's what it covered so far. So it defines an interval selections, basically allows you to draw a box. And then the code basically, in this case, going to respond to, so I'm going to run this one now, and this is the validation. This is the number of cylinder, this is the origin. So the color would map to the count, and it shows a scale. And so there's lots of cars. In the USA has 8 cylinders, and very few cars from the Europe has 5 or 6 cylinders, 0 for 8, for example. And if you do a selection, and only those being included in the selection will show a color, everything else will just show as gray. Yeah. So this is very similar in terms of interaction, the same as the one we showed before. We're really running out of time. Hopefully we can manage. Okay. Okay, and so this one, we're changing the interval selection a little bit. In this case, we're going to only selecting using interval selection to encode an X. We don't care the Y-axis selections. So previously we have the box. That means both the X and Y selection works. But now we want to only make it selecting the X-axis. The Y will always select by default. Okay, I'm gonna just try this one now. Actually, maybe let's do a new one. Okay, just to save a bit of time, I'm just gonna copy this and paste this one here. I think it should work. Encoding is equal to X. Okay, so can't stop there. I have to keep everything in. This line is okay, looks like. Yeah. Okay, so basically here we define the new and interaction. So this one, we only worry about the X-axis. I don't care about Y-axis. So the selection will only affect the axis. And then again, we're using the new selector, pass that to the same function if I run. And now if I interact on the page, I can still draw a box, but you can see it does not really affect the X. It always select all the values in the Y-axis. It only affects the things I select on the X-axis. Yeah, so that's what this one does. Okay, and you can actually also use the selection actually to make it the chart. I think you can pan and zoom. And this one, you are binding your interaction to the scales. Scales basically just means the scales is the X and Y axis. How do you map the data to the lens onto the scales? And you can imagine if you change the scales, for example, make the bigger or smaller, and then essentially what it does, it will zoom. And if you pan, and it will, and if you change the absolute value instead of the mapping, and it will okay. So, and let's give this one a try. So I think maybe better if we go back here. Okay, so we're gonna do a new selection now, and just call this scales. And this is still interval selection, but this time we're gonna bind it to the scales and essentially the both axes. Okay, and then when we do the add selection, we're gonna do scales. And we run this. Oops. Chart specification. Out selection interval bind equal to scales. Ah, of course. Sorry. So here I'm still using these conditions, which has to be removed. So really, for the color should only equal to this part. Okay. Yeah. Okay, and so far this one doesn't look any different, but you can see now I can hold down my mouse button and move it around, and because it's bound to the scales, the position of the selection or the factor, the starting point of the scale, essentially allow you to pan and zoom, and then if you use the wheels on the button, then you can zoom in and zoom out. So that's changing the mapping again, so that allows you to zoom in and zoom out, and essentially doing the zooming and pan. And so this is how it works. Okay, and just because we're running out of time now, so I have to go through these ones without actually doing too much explanation. And so to select a single item at a time, and you just do selection single, and then pass that onto the, let me see if I can do this quickly. These are all intervals. Yeah. Okay. Can I just be a little bit lazy? Can I just do selection single? Okay, and run this one again. Now the selection is always just 1 point. Oops. You can see I cannot drag, doesn't matter, but I can only click, which will select whichever blocks that was in. Okay. Yeah. Okay, we probably don't have time to cover too much of this, and so I'll leave it for you to look at it after class. And here we are kind of binding and the interaction to some external elements like a drop-down menu on the page or radio button. Okay, and so in these examples, you can filter the data by changing the values in the drop-down. So this is a bit more code, and so the drop-down itself is just bind, use the, oh, maybe half the time. Okay, and so this part and creates a drop-down menu. Oh, sorry, just the first line. And so out, binding, select, and you have these three options, which is Europe, Japan, and USA. So these will be the three drop-down options you can choose. So that creates this part. Okay, and this is the selection single, which you seen before, selection or interval. And the fields will be the original. Okay, so this is the origin in the data set, and it's going to bind with the drop-down. The input drop-down is this one here. So whatever being selected, one of three, will be used to set, essentially filtering the origin field. Okay, and then here is setting the color. So let me see, select condition and okay. So again, so this is similar to the condition we saw before. And so the selection will be this selection here. So if the item is selected and its color would be mapped to the origin, I don't want any legend. And if it's not selected, it will just shown as light gray. Okay, so the selection will set the origin of the data set to one of these values. And then only those being selected will have a color, depends on the origin. So the red will be America, blue will be Europe, etc., etc. Yeah. And then these are the actual chart itself. Using the cost data set, market point, horsepower is X miles per gallon is Y, and color equal to color. Okay, so that's the color, is the color for the chart, and this color is the color we defined here. And you can put these conditions here as well. That's what we get the same. And we add a tooltip as well. We can show the name of the model, I think. And finally, we add a selection, add interaction. This selection is this selection here. Okay, and so let me just copy and paste this before we finish. Sorry for running a little bit over time. Okay, and there's a little bit errors here. So you can't have line break there. Doesn't like it. And I think that's about it. Okay, and then you would have this drop down here, and you can choose Japan. So only Japan would show USA or Europe. Okay, yeah. Okay. And the last one is a little bit more complex. You probably need to go through this a little bit later yourself, just to fully understand the code. But in terms of the reading, these are the three sections from the Altair documentation we're going to cover today. And yeah, okay, we'll stop there.